Hi, sir. My name is Aljo Antony, and my dissertation topic is machine learning application for early cancer prognosis and detection using machine learning. Yeah, okay. So the project review of this, according to the World Health Organization, cancer is one of the leading causes of death in the world, and it's accounted for 10 million deaths in the year of 2020. Breast cancer is a main kind of malignant growth that is prevalent among the ladies around the world. There are multifactorial causes of breast cancer, including family ancestry, radiation treatment, weight, hormones, and even reproductive factors. Early detection and early treatment of patients suffering from this disease can facilitate lowering mortality rate related to this disease. The early detection of breast cancer can be supported with the use of machine learning algorithms. These algorithms can be used to detect the presence or absence of disease by considering different parameters such as radius, texture, perimeter, and other such parameters. So the aim of the project is to develop a machine learning model that can facilitate early diagnosis of breast cancer by predicting the presence or absence of disease in individual. Um, the objective of the project is there are three main objectives. First of all, first one is to conduct a literature review to identify the various machine learning techniques that were used by past authors to detect the breast cancer in individuals. The second one is to create a machine learning model to facilitate a early diagnosis of breast cancer by predicting the presence or absence in the disease in individual. The third one is to evaluate the performance of the model using accuracy metrics such as precision, recall, FN score, and accuracy. These are the three main objectives. You can see the literature review. The review of the what different authors has been presented in this slide. It showed different machine learning techniques that were used by the authors to detect the breast cancer. You can see in the PDF there are different techniques we are using by different authors, and their limitations and data types and everything obvious. So and the next one is the literature gap. The review of the literature revealed that most of the authors made use of genetic algorithms, decision trees, support vector machines, k-nearest neighbors, random forest, and other such algorithms. But classifiers that combine multiple algorithms, such as voting classifier, have been used rarely. So this project will provide a machine learning model that will combine several algorithms to achieve higher accuracy and effectiveness in detection of the breast cancer among females to facilitate early detection and treatment. This will enable a decreasing mortality rate among women due to the breast cancer. And the methodology, this means aim to develop a machine learning model that can facilitate early diagnosis of breast cancer by predicting the presence or the absence of this disease in an individual. It will be accomplished by using CRISP-DM methodology. The code will be written for development of machine learning model through usage of Python language. There are 6 phases contained in this methodology. Each phase will involve performing different tasks related to the project. And there are the 6 phases here. The first one is business understanding, like the develop a machine learning model for the early breast cancer detection to reduce the mortality rate, and the model support early diagnosis and treatment and enhancing the patient outcomes. And the second one is understanding data. So there are so many data set we can see, and analyze will include the visualization and quality assessment for missing values and outliers. And next third one is preparation for data set. We split the data set by 80-20 ratios, for 80 for training, 20 for testing, and the missing values is inputted, which means real values. A feature important in a chart is identified key variables, influence diagnosis, and the fourth step is implementation of model. So we takes two of them, CNN and a voting classifier that's include random forest, logistic regression, SVM and gradient browsing, and KNN and ADA boost. This is implemented, and soft voting will be used for predicting the aggression. And the fifth and sixth is model evaluation and deployment. So So in model evaluation, the performance is assessed by using the confusion metrics, precision, recall, FN score, and accuracy to determine correctly and incorrectly classified instances. And last one is deployment. And next one is we can see in the data analysis you can see the correlation between different variables in the data set is presented in this slide. The variable with the highest and lowest correlation with the target variable can be observed from the slide. So, and these are also the this slide present the relationship between mean of the different variables, the mean of the different variables and diagnosis variable with the help of the bar chart. And most of the variable have higher values with respect malignant growth. So this also indicate that tumors with large mean value of this variable are more likely to be malignant. And this in this chart, some more variables, main and their relationship with diagnosis variable has been presented in this slide. You can see over here. And in the next chart, we can see the slide present the relationship between standard error or different variable and diagnosis variable with the help of the bar chart. And most of the variable have higher values with respect to the malignant growth. So this also indicate the tumor with a large standard error value of these variables are more likely to be malignant. And in this case, some more variable have SC, and their relationship with diagnosis variable has been presented in the slide. So we can see over here in the slides. And this one, the slide present the relationship between waste of the different variable and diagnosis variable with the help of the bar chart. And most of the variable have higher value with the respect of malignant growth. So this also indicate tumor have large waste value. These variables are more likely to be malignant. And this one, in this bar chart, we can see some of the variables, waste value, and their relationship with diagnosis variable has been presented in the slide. So we can see here their values and everything. And this graph present the top 10 important features that are important for the diagnosis of the breast cancers. The most important features was the area, waste, waste, and the least important features among 10 features was concavity waste. So area waste and concavity waste are the two main things for the important is area first, and least important thing feature is concavity versa. And this is a confusion metric, and confusion metrics of the CNN and voting classifier has been presented above the figure, and the correctly and incorrectly classified instance by the model has been shown above. In CNN, the true positive of the model is 39. That is the model correctly predicts 39 malignant cases. And apart from this, the true negative of the model is 79, which indicates there are 71 correctly predicted benign cases. The false positive of the model is 1, which means one benign cases is incorrectly predicted as malignant. However, the false positive model is 3, that is 3 malignant cases are incorrectly predicted by the model as a design. In the case of voting classifier, there are true positive model is 38, that models are correctly predicts 38 malignant cases. Apart from this, the true negative of the model, which model is 72, which indicates that there are 72 correctly predicted benign cases, which and the false positive of the model is 0, which means there are 0 benign cases incorrectly predicted as malignant. However, the false negative of the model is 4, that is 4 malignant cases are incorrectly predicted by the models are benign. And these are the accuracy metrics, sir, and the accuracy metrics of CNN and voting classifier model has been presented here, and the accuracy value of CNN model was found to be 96%, while recall value of the model was 93%. Apart from the FN score of the CNN model was 95, and precision value of the model was 97. However, the accuracy value of voting classifier model was found to be 96, while the recall value of the model was 90%. So additionally, the FN score of the model was 95, and the precision value of the model was 100. So you can see in the graph. So, and the conclusion and the feature direction. So there has been a high prevalence of the breast cancer in the world, and it's a leading to the high mortality rate among the women. These projects provide a machine learning model that can facilitate early diagnosis of breast cancer by predicting the presence or absence of this disease in individual. The data set for training the model was acquired from Kaggle. The code for the model was written with the help of Python language, and two models were developed with CNN techniques and voting classifier. The performance of both models were compared to know about the best model to predict the presence or absence of the breast cancer in females. The accuracy and the fin score of the model same for both models, while recall value is higher for CNN model and the precision is higher for voting classifier. Since the precision is more important in detection of the breast cancer, so voting classifier recommended for prediction of malignant or beginning cancer. So these are the reference we I choose for, and these are the reference that that's it, sir. And the next is the coding. The coding things are over here. These are the coding for the dissertations and for the CNN and the voting classifiers. We can see over here codings, different types of data sets over here, and after running we can see the diagnosis count in the malignant and benign, and different features they're running. And the count for the diagnosis, the starting and the peak times, the code for then different features. There are perimeter, radius, area, mean, smoothness, and all kind of things in the runnings. And this is the correlation matrix for the features after running results. So we can see here all the dates. And the code, after that we can see the confusion matrix, the starting and the peak times, malignant times, and the model performance metrics results over here for the code. And this is a value, shape values, and the confusion matrix for the predictor label, and also the model performance metrics over here. And the confusion matrix and the precision recall curve. And after running the model performance metrics for the voting, and these are the top 10 important features of the random forest, and their confusion matrix and all other things over here. So yeah, these are the finals. So thank you.